Good morning or good afternoon. This is the Ed Puzzle lesson about 7.1 where we are working on writing ratios and solving proportions. This is a concept that is learned in Algebra 1. Actually, it's first learned in middle school. So please remember this is not a required lesson if you pass the test out in class today. However, everyone still is required to complete the 7.1 Math Excel that has 23 questions. Here we go. Let's first review what a ratio is. A ratio is a comparison of two quantities by division. We can write the ratio of any two numbers A and B so long as B is not 0 in three different ways. One of those ways is A divided by B. That is the reason why B cannot equal 0. We can also separate the two with a colon, A to B, and that is read as A to B. Okay? Those are the three different ways that we can write ratios. Just so you know, when we write ratios, we do write them in simplest form, which means that you will need to simplify your fraction. So here is our first problem. Example 1. The bonsai bald cypress tree shown here is a small version of a full-size tree. In Longwood, Florida, a bald cypress tree called the Senator stands 118 feet tall. What is the ratio of the height of the bonsai tree to the height of the Senator? So what I really care about here is the ratio of the height of the bonsai tree to, or divided by, the height of the Senator. Because this question specified what order to write my ratio in, I must obey, okay? In my diagram, I am shown the height is 15 inches. Please notice that they tried to give you some extraneous information to throw you off of 1 foot. 1 foot is not the height. So we have a height of the bonsai tree of 15 inches divided by the height of the Senator is 118 feet. Now we have an issue. Our issue is the fact that we have inches and we have feet. We need to convert these such that they are in the exact same unit. So, to convert feet to inches, let's create, I think it's called stoichiometry actually in chemistry. I'm not quite sure what it's called normally, but we're just going to convert. So we have 118 feet for every 1 inch, okay? So we need to multiply 118 feet by 12 inches, which goes in 1 foot, okay? Notice in this situation, we have the feet canceling each other out. So all we really need to do is 118 times 12 to find in inches the height of the Senator. The height of the Senator is 1,416 inches. So I'm now going to plug that in. Now we have 15 inches divided by 1,416 inches. And then we need to simplify this, okay? All right, when doing a ratio, we no longer need units. Notice that they cancel each other out because they are now the same. So a number that goes into both 15 and 1,416 is 3. So this simplifies to 5 over 472. So here is the ratio of the height of the bonsai tree to the height of the Senator. Note that we can also write this as 5 with a colon to 472. This is also an acceptable answer. It is now your turn for your got it. All right, let's check over your work. Please make sure you are reading through this example if you need to see where you went wrong. All right, let's look at example 2. In example 2, members of the school band are buying pots of tulips and pots of daffodils to sell at their fundraiser. They plan to buy 120 pots of flowers. The ratio of the number of tulips to the number of daffodils will be 2 to 3. How many pots of each type of flower should they buy? All right, because I have a ratio of 2 to 3, I need to incorporate this into an equation, okay? So essentially what my equation will look like is going to be 2 times x plus 3 times x equals 120. Where what I have on this side of my equation is the 2 to 3rds ratio, okay? I have 2 times as much plus 3 times as much of some quantity equal to 120, okay? All right, so now I'm going to solve for x. So now we have 5 x equals 120. Divide both sides by x. X is going to be equal to 24. Now, side note, this is not the final answer. What I need to do is I need to figure out the number of tulips and the number of daffodils. So, number of tulips. Because the number of tulips was in the numerator part of my ratio, I'm going to multiply 2 times my x value to get the number of tulips. So 2 times 24 tells me 48 pots. Now I'm going to do the same thing for the daffodils. Number of daffodils. Because that was representing the denominator of my ratio, we have 3 times x, so 3 times 24, getting us 72 pots. So notice our answer here are these two components. And when dealing with this problem, I created an equation that incorporated their ratio. Their ratio multiplied by x, multiplied by some number, is going to add up to 120. It is now your turn. All right, let's check over your work to see where you went wrong if you got this question incorrect on Edpuzzle. All right, check over your work. The other way you could have set up this problem, because it is a ratio of 1 to 4, you could have set up the equation similar to how we did in the previous problem, of x plus 4x equals 180. And therefore 5x equals 180, and then again, solve for x. All right, let's continue on. All right, so now we're going to talk about extended ratios. They don't happen that frequently, but they're very special when it comes to dealing with shape relationships. So an extended ratio compares 3 or more numbers. For example, we have the ratio between a, b, and c, where it's a to b to c. The ratio of the first 2 numbers would just be a to b. The ratio of just the last 2 numbers would be b to c. And then we also have the ratio of the first and the last number just being a to c. So this is an example of an extended ratio. All right, so now we're going to use an extended ratio. The lengths of the sides of a triangle are in the extended ratio 3 to 5 to 6. The perimeter is 98 inches. What is the length of the longest side? All right, so we're going to set up an equation just like we did before, where we're going to incorporate this ratio and set it equal to our perimeter. So we have 3x plus 5x plus 6x equals 98. All right, when I start to simplify this, I end up with 14x equals 98. Divide both sides by 14, and we get that x is equal to 7. Now remember, this is not our final answer. I now need to figure out who's going to have the biggest side, okay? So in the triangle, the one with the biggest side is going to be the one that has the most pole in going to the perimeter, which is going to be the guy containing the 6. So 6x is going to control the biggest side. So we're going to have 6 times 7, and that's going to get me a longest side of 42. Okay? All right. It is now going to be your turn. Check your answer, see where you went wrong if you missed the question on your Edpuzzle. All right, so here we go. We're going to continue. Now we're going to get into properties of proportion. So let's first talk about what a proportion is. An equation that has 2 ratios is called a proportion. So this guy right here, proportion is this guy. Okay. Now there are certain parts of this proportion that we need to talk about. When I have the proportion A over B equals C over D, the letters B and C are called my means. The letters A and D are called my extremes. When I create this in the colon format of a ratio, notice my extremes are on the outside. A to B is the same thing as C to D. And my means are on the inside. The only reason I'm talking about this vocabulary is because we're going to utilize these words when talking about certain properties of proportions. Okay? So here's our first property. This is actually a property that you know about. It's called the cross product property. So if we have the proportion A over B equals C over D. All I need to do is multiply both sides by the denominators. Essentially, what I'm doing is bringing the extreme and the mean of one side over to the other side. So, in general, what I'm saying is A times D is going to be equal to C times B. The extremes times each other equals the means times each other. Okay? We talked about this a long time ago in your basic math classes, so now we just need to utilize this property. So here we go. Let's do the first example. What is the solution for each of these proportions? What I'm going to do is I'm going to cross multiply. We're officially just calling this the cross products property, but it's really just cross multiplying. So when I have 6 over x equals 5 over 4, all I need to do is multiply both sides by the denominator. So essentially, 6 times 4, those are my extremes. That is going to be equal to my means 5 times x. Okay? Going back to this page, remember, B and C were my means. A and D were my extremes. And that's why I said 6 times 4 are my extremes and 5 times x are my means. Okay? And now we just need to simplify. 6 times 4 is 24. This is 5x. Divide both sides by 5. So we have 24 fifths is equal to x. If you are more interested in the decimal answers, our decimal answer is 4.8. Okay? Now let's move up to a little bit of a heftier proportion. Oh, where'd my slider go? Hide the bottom. Don't want to get you too excited about your got it question yet. All right, so once again, I am going to multiply the denominators onto the other side, essentially getting my extremes and my means together. So we're going to have the quantity y plus 4, the entire thing is being multiplied by 3, equal to 9 times y. Notice, I'm very cautious about this because I have to remember that both pieces are being multiplied by the 3. So we have 3y plus 12 equals 9y. Now I'm going to subtract 3y from both sides, so 12 will be equal to 6y, getting me an answer of 2 is y. Alright, let's practice your proportion skills. You are solving each proportion. Alright, if you didn't get one right, let's check your answers at this time. Let's follow through the work and see where are we going wrong. Oops, there you go. Alright, hopefully that was a sufficient amount of time to look over where you made a mistake if you did on either A or B. Alright, the final thing we need to talk about are just the final properties of proportions. We've talked about the cross product property. Now we just got to talk about 3 more. The first thing that we need to recognize is that we can essentially flip-flop the numerator and the denominator. A over B equals C over D. That is our base proportion. That is the same thing as if I decide to just make the reciprocals. B over A equals D over C. Okay? Essentially what I did in this problem here is essentially I just flipped along the diagonal in both situations. Okay? That's all I did. Alright, next property. A over B equals C over D. Once again, remember that is my basic property. That is the same thing if I just decide to switch the locations of the means. Switching the location of B and C. So I multiply by my denominator B and then divide both sides by C. That is the same property. Alright, the last property we need to talk about. Remember my core proportion, A over B equals C over D. In the first fraction, if I add the numerator by its denominator, that is the same thing as the other fraction adding its denominator onto the numerator. So notice, A plus B over B is the same thing as C plus D over D. Okay? These are our properties of proportions. Now let's utilize them. Okay? Here is my example. In this diagram, we know this statement to be true. We know x over 6 equals y over 7. Later on in this chapter, when I'm actually not here, you will talk about this. X over 6 is equal to y over 7. Okay? Now, what has happened is I now have x over y. So I'm going to rewrite my base proportion. here is the base proportion. X over 6 equals y over 7. Somehow, I got x over y equals something. So let's make an observation. What changed? All of a sudden, the 6 is no longer in the denominator. I switched it with the y. So if the y is now in the denominator, that means the 6 must still be now in the numerator. Notice the x stayed in its location, which means the 7 must have also stayed in this location. So here is what my proportion is now equal to. All right, it is now your turn to utilize our properties. All right, let's check your answers. And if you got one of them wrong in your Ed puzzle, please make sure you're using this time to check out why. Why did you miss the question?